Hello. Today we're not going to need our textbooks. What we're going to do today is kind of wrap up everything that we've discussed about Module 5. And this in particular is the second half of Module 5, where we're going to talk about the forms that are required in order to get from concept to fabrication. There are three primary forms: the procedure qualification record, the welding procedure specification, and then the welding performance qualification record, which is the welder certification papers. I'm going to run through all three of those so that you'll have an idea of how they're filled out, and if the time comes, you'll be able to read them. If you look in your student packet, you've got a number of forms in there. The first one I want you to pull out is QW 483, Suggested Format for Procedure Qualification Records. And this will be the first one that we're going to do. So dig around and find that. And what the PQR is, it's a record of the actual variables that were used in the welding of a test specimen. Now, in the film that you saw, they did the WPS first, and then they did the PQR, and then after that they said, now we have a qualified welding procedure. So there's two ways of doing it. Your WPS, you could do what's called a preliminary, and I think I spoke about this, excuse my spelling, preliminary WPS, or you could do a TIF, which is a test information form. Call it what you want to. This is a list of variables that you want the welder to adhere to while he's making that test weldment. Then we go from that to the PQR, which is this form, and the one I've asked you to pull out. And this is where we fill in the blanks with all the actual information that were used in the welding of that test specimen. So if you look on the front page here, we've got company name, then procedure qualification record number, and the date, and so forth. So under company name, I'd like you to fill in that space with a name that you come up with. Now, I just happen to write any welding company. That's going to be my company name. And then for the procedure qualification record number, I just like to use abbreviations. And I do this in real life. I use the company's abbreviations. So I will go AWC-1, which means any welding company and the very first procedure that we've done for them. And then, of course, on date, go ahead and put today's date. Then WPS number. You have to have a number that's unique to the welding procedure. So, again, I use AWC for any welding company dash CS, meaning carbon steel, dash 1. Because this is the first carbon steel procedure we've done for any welding company. Next, welding process or processes used. Well, we're going to use the shielded metal arc welding process. And then right beneath that it says types. They're asking us, did we do it manually, automatically, or semi-automatically? Well, we did it manually. So, everything above that blank space there should be filled in with this information. Now come on over to the blackboard. Now under this blank space here it says joints. And I want you to notice it says QW-402. What this form does is it refers you to the appropriate paragraph in Section 9 for more information. So if you're not sure what's supposed to go in that particular area, refer to Section 9 of the ASME Code and look up that paragraph and it will explain it to you. So, it says here, groove design of test coupon. And it says, for combination qualifications, the deposited weld metal thickness shall be recorded for each filler metal or process used. So if we're going to use two different processes, and it's very common to use TIG for a root and then switch to shielded metal arc for fill and cap, then we would have to record whatever metal thickness or deposited weld metal we use for each one of those. But in this space here, we want to draw a picture of the type of joint. Typically, on a pipe weld, you're going to use a single V joint like this. And we're going to draw that in there, but if we told that welder, well, we want to have a root face that is 1/8 of an inch. And so we have to record on our drawing 1/8 of an inch for the root face. And if we had a root opening of 1/8 of an inch, then we would have to draw in that space 1/8 of an inch, so that whoever's looking at this knows that this test specimen was made with a 1/8 inch root face and a 1/8 inch root opening. Then here, what was our included angle? What was the angle of both of these bevels put together? And we'll record that. Now, I'm just going to put 75 degrees up there, which would be typical. And so this is the kind of information that we would put in. You don't really have to record the thickness, but you can if you choose to. It will be recorded later on in our other information. So in this space where it says joints, go ahead and draw a picture similar to this. This is a single V-groove butt weld with an 1/8 inch root face and an 1/8 inch root opening and a 75 degree included angle. Okay. Now, the next bit of information we need is the base metal. That is the first block on the left-hand side beneath our space. And it's asking for the material specification, the type or grade, the P number, the thickness of the test coupon, the diameter of the test coupon. All of that information concerning the base metal has to go in here. So in your packet, you're going to find some other forms. The first one I'd like you to pull out is this form. And it says Metals Database. Now, there's an awful lot of different types of product forms out there and metals. And this is just happens to be one that I printed off of my computer. I have a program and I printed this off. And typically we would use SA 106 grade B. So I want you to come down here and find SA 106 grade B on your materials database sheet that should be in your packet. And once you've found that, I want you to record that where it says material specification under the base metals, material specification. Okay, type or grade. Over here in this column it tells us that SA 106 grade B, that would be the grade that we would go in there. And then we have the UNS number, the P number, the group number, the tensile strength, and then the product form. And there's a lot of different product forms listed there. So what we want right now is SA 106B under material specification. And the B would go on where it says type or grade. That would be the second line, type or grade. You're going to put B in there. And then the P number, if you go across here, you'll see that the P number is 1, P1. So here where it says P number, you're going to write 1, and we're going to weld it to P1. So it's P1 to P1, and that's what should go in those. And if you take a look at this metals database, under P number, you see there's a lot of different numbers here. There's 1s, 3s, 8s, 4s, 5s. P numbers are what are assigned to materials based on their chemical composition. The stainless steels are all P8s. So you see here grade 304. These are stainless steels and they have a P8 number. The 4s, they have alloying elements in them such as some chromium or some monel. So it's going to change. A material's P number is going to change depending on what its chemical composition is. Plain carbon steel is going to be a P1 number. So we want to put that in there. And then next we have the thickness of the test coupon. How thick is it? Well, go to your handouts again, and you should have this form. It says pipe size and wall thickness. You should have one of these in your student packet. Well, since we want to qualify the welder and the welding procedure at the same time, we're going to use 6-inch Schedule 80 pipe. That way we'll qualify the welder to go out there and do production work, and he'll set up the procedure for every other welder to be tested. So we're killing two birds with one stone. So you're going to come down here where it says nominal pipe size, and you're going to find 6 inch. And then you're going to come across here, and you can read all of your information. The outside diameter is 6.625. We're using Schedule 80, so you're going to come over here where it says Schedule 80 and come down, and it shows us that Schedule 80 pipe is 0.432 inches thick. So that's the information that will go on that line. Where it says thickness of test coupon, you're going to put 0.432. And then the diameter of the test coupon, we've already seen that over here. They're looking for the outside diameter, so it would be 6.625. That goes on the next line. And then beneath that, you can write anything else that might be of interest. And a lot of times, I like to go back and here on the on our metals database, I like to put the UNS number. If you remember from what we were talking about in the first part of Module 5, we talked about the Unified Numbering System. That is its UNS number. So we know that we're using SA 106 Grade B. So you would write in where it says Other, you would write UNS number K03006. So it makes it easier to cross-reference the type of material that you're using. Okay, so that takes care of topic number 5. So number 6 now, we have to do the same thing for our filler metal. So if you look at our form, right beneath metals is filler metal, and you'll find that in paragraph 404. So the first thing they're asking for is the SFA number. Let me put this down. Getting too many forms in my hand. So again, in your packet, you should have a form that says filler metal database. And again, I printed this off of my computer so that you could have a little practice in looking some of this stuff up. Well, we're going to use E6010. So let's see, where is E6010? E6010 is right here. And if you just follow that across, it says SFA number 5.1. So you're going to write 5.1 right here where it says SFA number. Now you notice it's got 2 columns. And since we're using 2 different types of filler metal, you'll write SFA number 5.1 here. And then the other welding electrode we're going to use is 7018. So you come down here and you'll find E7018, and you'll see that it is also a 5.1. So we're going to write 5.1 over here. So we have 5.1 and 5.1. Now, AWS classification, filler class. When we call an electrode E6010, that is its AWS classification. When we call it E7018, that is its AWS electrode classification. So those are the numbers that you're going to put in there. E6010 and E7018. Then filler metal F number. Now if you remember from our previous discussion, all of these filler metals have F numbers based on their chemical composition, and you just come over here and you'll find it, F number, E6010, you come across there and you'll see that our F number is 3. So that'll go in the same column where you're listing the information for 6010. Come down here and find 7018 and you'll see that that's a 4. So that will go under your 7018 column. Next, weld metal analysis, or A number. They're called A numbers. Come back over here and you look further across and you'll find the A number for it. So for 6010, the A number is 1. For 7018, the A number is also a 1. So you're going to write that in there. Now you see that they have some different ones in here, such as verify chemistry, or here it says chrome, nickel, and copper. So it changes. So it's 1, 2, whatever. And it also changes what the type of a filler metal it is. For example, a bare wire would be a 6, is a bare wire. Covered electrodes are typically a 1, but not necessarily all of them. So next we go size of filler metal. Well, what size welding electrodes did we make that welder use? For the root pass, we'd probably make him use a 1/8 inch 6010. So that's what we would write here where it says size of filler metal, write 1/8 inch. And then to fill it and cap it, typically 6 inch Schedule 80 pipe, you would stick with a 1/8 inch, but you might also allow him to use a 332. Whatever you decide is what you have to write in there. Whatever he actually used is what has to go on the PQR. Remember, the PQR records the actual variables that the welder used during testing. And then any other information you can go ahead and list beneath there. Now, weld metal thickness. Typically, a root pass would be about 1/8 of an inch thick, so you could write anything from like 0.067, which would be about a 1/16 of an inch, to 0.125, which is an 1/8 of an inch, and you would write that in there. A lot of times I'll just leave that blank, but if you really wanted to be accurate about it, you would actually cut a slice of the weld out, and you could etch it with acid and then physically measure how thick it was. But I don't usually get that in depth with these PQRs, especially if it's a PQR that's been done 100,000 times before. So I'll just go ahead and I typically put 1/8 of an inch or 0.125 for the metal thickness on the root pass, and then you have to deduct that. You have to deduct that thickness. Now, if you remember, the thickness of our joint was 0.32. That's how thick 6-inch Schedule 80 pipe is. Well, if our root pass was 0.125, then you have to deduct that 0.125 from the 432, and you get 307. So the remaining passes, your 7018, then you would write in 0.307 over in the column under the 7018, because that's how much 7018 metal you deposited. That's if you break it up. Sometimes you break them up, sometimes you don't. It depends on how thorough you want to be and also on what the company wants. But if you have any specific questions about that, again, refer to the paragraph in ASME Section 9, 404, so it'll give you that detail. Next, we have the position of the welding. Well, we know that in pipe there's the 2G, which is the vertical fixed, but you're welding around like this. We have the 5G, which is the horizontal fixed, and you're welding up and down or down to up. And then we have the 45 bell hole. So that would be the 6G. So here we would put the 6G, because in order to qualify a welder to weld in any position, they have to take a test in the 6G position. So right here where it says position of groove, it's going to be 6G. Right beneath it, it says weld progression. Did we make him weld it from the top to the bottom or from the bottom to the top? And that would be written in here. For our purposes, let's say we welded it from the bottom to the top. So we put vertical up in that space. And then other. Anything else that you wanted to note in there? One non-essential variable is that the second pass could be vertical up or down, if they call it a non-essential variable, provided the root pass is ground to clean white steel. So you might put in right here that very information. You might say vertical up or down, provided clean white metal, blah, blah, blah. You could write that in there. But since on a PQR we have to record what actually happened, you would have to make a note. If you gave the welder his option of doing that and he chose to run it down, then you would have to note that, okay, well, we did the second pass down after grinding to clean white steel. Then we come to preheat, QW406, preheat temperature. I usually like to make a welder drive the moisture out of the joint. They don't have to really raise it up to 200 degrees or anything like that. That's unnecessary. But pipe sweats, and if you take a torch and you sweep it across the material, you'll see that it'll drive moisture away from the joint. I like to do that to help avoid any porosity in the weld and to drive that hydrogen away from the joint so we don't have any underbead cracking later on. So I would typically tell them, take it up to 75 degrees or take it up to 80 degrees, whatever, and you would write that in there if you had any, and if you did it. And then your interpass temperature. Now your interpass temperature, as the name implies, are those passes that happen after the root pass is put in, but before it's capped. So those are the ones that are in between during the process of filling it up. Now you would check that from time to time and record the interpass temperatures in here, and that would help you to establish a maximum interpass temperature later on. Then any post-weld heat treatment. Well, post-weld heat treat is required on certain materials. Some of the alloys have to have post-weld heat treatment because they could be more susceptible to cracking. If you do any of that, then you have to record that information here where it says post-weld heat treat. Also, if the material's thick, you might have to do some post-weld heat treatment on that. And that's an essential variable. If you do any of that stuff, it all has to be recorded right here in in this paragraph, and you can refer to that the questions about that to QW 407, which is where you'd find that information in section 9. For our purposes, we are not going to do any post-weld heat treatment, so you're going to put none or not applicable in A, not applicable. Gas, if we used a TIG route, then we would have to record all this information in here on what kind of gases that we used. Since we're not, this is all NA, not applicable. You want to try not to leave any blanks at all. So you want to put something in every blank or draw a line through them so that if anybody is reading this information 10 years down the road, they'll know that you deliberately didn't record anything in there. They don't want to be scratching their head thinking, well, did he just forget to put that in? So you always try to fill in every space. Now the electrical characteristics, the current. Shielded metal arc welding is typically done with, when we're using 6010 and 7018, it's done with direct current. So that will be the type of current where it says electrical characteristics, we would put direct current. And then polarity, we usually use reverse. And so that would go in the line underneath that. Now you're going to record the amperages that this person used, and they're going to be different for the 6010 and different for the 7018. And you might even want to attach a separate sheet. A lot of inspectors I've worked with like to record every layer, every weld layer in the amperages that were used. So you could attach an extra sheet, or you could just squeeze it in here where it says other and write that information down there. So for our 6010, we might run, let's say he ran it at 78 amps. So you're going to write the actual amperage that he used. And then for the 7018, our craftsperson ran it, let's see, 1/8 inch, 7018, let's say he ran it at 117. So those are the amperages, and they're going to vary in there. And I would check them 2 or 3 times. Check them on the root pass, check them at least on the hot pass and one other filler, and then check them on the cap. So you're checking it 4 times. And you know, you want to get it as accurate as possible, but later on we're going to establish ranges. Then tungsten electrode size, well, if we were doing TIG, then we would have to record the size of tungsten that we used. But since we're not, you don't have to put that in there. Then we go to technique. You can record technique, anything about technique in there. Usually I would put something like NR for not recorded because it's not really necessary. Pardon me, under technique it says travel speed. A lot of times I won't record it, but API I've found, when you're working with the 1104 code, they do like that recorded. And you're going to put inches per minute, 6010, say 6 inches, 6 inches per minute, okay, and then inches per minute, 7018, they went a little faster, they did 8 inches. And what these numbers do is they can take these numbers and plug them in along with the amperage that was used, and they can calculate the heat input that went into the weld. So under travel speed, you can record that. Like I say, sometimes it's not recorded. And then you want to write down string bead or weave bead. Well, since we're welding in the 6G position, we have to counteract gravity, so therefore everything's going to be done with a stringer bead. So you would put stringer there. Then oscillation. Under oscillation, not applicable. Oscillation, it's more of a mechanical term. They have what they call a wiggler, and they can set it up on an automatic or semi-automatic machine, and it'll sit there and actually work the gun back and forth. And then you could set the oscillation time. How fast was it oscillating? So it's not applicable to what we're doing. Single or multiple electrodes. Well, you know, many people I know can have a stinger in both hands and weld with 2 of them at once, so it's a single electrode that was used. And then other, anything else you want to put in there, you can put in there. Any other notes or anything like that. And so we've come through all of this stuff. We've done the base metal, we've done the filler metal, we've done the welding position, we've addressed the preheat, the post-weld heat treatment, the gas, which is not applicable to what we're doing, the electrical characteristics, we've discussed the technique, and now we go to the actual testing later on. Now at this point the welder's done. Once we get past technique, the welder is done. But if you'll flip your paper over, you're going to see it's got a place back here for the tensile test. Now the ASME code requires a certain number of test specimens to be taken. Okay, in your packet, I've given you performance, qualification, thickness limits, and test specimens. But to qualify the procedure, you'll also have the number of test specimens that need to be taken out. And it will tell you what type of specimens have to be taken out and where they need to be taken out. In your book, there's some pictures that show where they have to be removed from. Under the performance test, the test we're talking about right now, the welder would only have to do face and root bends. But under a procedure test, you have to take out tensils. And I've shown some of those before. In fact, this would be a tensile right here. And to qualify a welding procedure, you have to do a reduced section tensile pull, just like this. And you'll notice on that form, on the back side, where it says tensile, it says specimen number 1, and then width and thickness. Then you're going to calculate the area. So we're going to measure this, and you notice it's machined down so that we get it nice and smooth all the way down through there. So we're going to measure it, calculate what that area is, then we're going to put it in our tensile puller, and we're going to pull it apart, and we're going to note how much force it took to tear that apart, and then from that, we can calculate the ultimate total load, and that will be recorded right here. And then from that, you'll get the ultimate unit stress, and then you need to record the type of failure and where the failure occurred at. So let's go to the blackboard again. I'll put a couple of examples up here that these came from actual tests that I've conducted in the past. So under specimen, we will go T1 for tensile 1. Width, we have 0.390. Thickness, 0.750. Area, 0.292. Ultimate load, let me get this out of the way. Ultimate load, 24,000. Ultimate tensile load, 82,191. And type of failure, PM for parent metal. So that's what the information should look like for the very first one that you would do, your very first tensile specimen. Now, to qualify this procedure under ASME, we have to do 2 of those. So our next one would be recorded as T2. And for this one, we have a width of 0.385. The thickness varied just a little bit. We didn't machine it quite as much, so it came out at 0.780. The total area was 0.300. It broke at 24,450. The ultimate load was 81,500. And it was, again, a parent metal break. So there you go. That's the kind of information that will be recorded under the tensile strength. And what they're doing here is they want to make sure that the procedure is going to maintain the tensile strength and yield strength of whatever material that you're trying to weld together. They're important mechanical properties. They have to be maintained. And a tensile test will tell us whether or not the procedure you're considering is going to work or not. I've actually had one of these fail before to where the heat input was too great and it failed, and they had to do something different and make some changes because their original concept wasn't going to work. And it's by testing that we work that out. Now, underneath that, you see it says guided bend tests. Well, to qualify this particular procedure, you have to do 2 face and 2 root. Okay, and this is right out of ASME, and it says QW 160. So you can go to QW 160 in section 9 and see that. And the way I would record that is I would go F1, F2, R1, R2s for face 1, face 2, root 1, root 2. And where it says result, you can write whatever you want to in there. I usually write satisfactory. or you could write acceptable. And I've even seen some papers where it just says okay. So anything to indicate that it was that it met the code is what you would put in there. Toughness tests. Now sometimes things have to be undergo toughness testing depending on the surface condition it's going to be exposed to, and you would do that. And all that information would have to be recorded in there. And you notice there's notch location, specimen size, the testing temperature, the impact values. If you remember, we talked about some of this testing before. You're going to do these tests in sets of 3s, and you're going to record the actual temperatures when you tried to do the brakes and so forth. That'll all go in there, the drop weight. Then it says fillet weld test. So this is not applicable to what we were doing, but sometimes you may want to qualify a fillet weld. And you're going to do a macro etch, and usually you're going to do a brake test. And so here, penetration into the parent metal, yes and no. Was it satisfactory? Yes and no. On the macro, were those acceptable? And again, you can go to QW 180 to learn about the details of that. Other tests, some companies, although it's not required, may ask you to do a nick brake, and if you wanted to do that, you would do it there, or if they may ask you to do a chemical analysis, and all of that information would go there. So, then we have our welder ID, and I have Joe Welder as my person that made this weld for us, and his clock number is 007 because he's a man of mystery. Usually they'll use, for their stamp, they'll use their initials, so my initials here would be JW, and then the test was conducted by, well, we're here at Western Wyoming Community College, so I would write that information in there. And then you have to have a unique laboratory test number. So I would probably do something like WCC-01-06, meaning that it was the first test that I did in 2006. So something like that. So it's got to be a unique number that you can refer back to. Then the manufacturer would be who was this done for? It was done for any welding company, and then you would sign off on it. And as a CWI, you would also put affix your stamp, your CWI stamp on there. So that then takes us through this first form. And remember, the first form, you're sitting there with your little micrometer and your meter gauge, and you're recording all the actual values. You've got your pyrometer, your temp sticks, everything, your tape measure, your stopwatch to get the inches per minute, and all that information goes into the PQR. Okay? Actual values have to be recorded in the PQR. The PQR backs up the welding procedure, which is our next document. Okay. Now, we come to our Welding Procedure Specification Form. And this is called QW 482, Suggested Format for Welding Procedure Specification, and in parentheses, WPS. Now, it asks for pretty much the same information. It says, okay, what's the company name, and who wrote this procedure for the company? If you're the person writing it, your name would go there. Who's the responsible party? Welding procedure specification number, well, this is what we decided. Any welding company, carbon steel -1. So that would be the welding procedure specification number. Then we have the date, and then the supporting PQR number, or numbers, because sometimes you'll use you'll combine them. So our PQR was any welding company -1. So that number then would go in there, and you can see they just basically flip-flopped from one form to the other. Revision number, well, this is a brand new procedure, so there's no revision number, but if there was, you would have to record the date of the revision. Welding process or processes, so we're using shielded metal arc, so that will go in there. And then it says type or types. We did manual welding, so that would be written in there. And then we have a space for another sketch. So you would draw your single V groove butt joint in there with all of the details. But now the details are going to change a little bit. If you remember, the PQR records actual values. The WPS records a range of values. The WPS actually gives the welder some tolerances. So if we write in our single V groove this time, whereas before we said this root face was going to be 1/8 of an inch, now we might say 1/8 of an inch plus or minus a 16th. So now we've given the welder a little leeway. Same thing here on the root opening. We might say 1/8 of an inch plus 1/16 minus 0 if we wanted to. So he can go a little bit bigger, but he can't go any smaller. So we're establishing ranges that they could do it with. And those details then would be added here. And then it says joints, joint design, and we would write in single V groove. Now if we used a backing, we would have to say yes or no that we've used backing. And if we did use backing, then we would have to put what type of backing. And a mild steel would be A36. Okay, A36 would be a typical backing, and you would have to put, well, what size? Okay, well, 1/4 by 1 inch thick backing, and that would be written in there, and you would have to go ahead and mark where it says metal. The rest of that's pretty self-explanatory, and these welding procedures can apply to more than one joint. For example, we might want to apply it to a single V joint, like so. That's perfectly okay. You can apply it to that, or you might want to apply it to a double V. That's perfectly okay. We've already established that the procedure works. As long as you're using the same type of material, it'll work. And so it gives you more leeway. Next, we have our base metals. P number 1, again, you can go back to that form I passed out earlier. P number 1, group number, I believe it's 2, to P number 1, group number 2. Or you can write in SA106B, or you could put the chemical analysis of the base metal. And then the thickness range, the base metal, whatever groove size it was, pipe size would be unlimited. See, we're establishing ranges now. And so the base metal might be, the thickness range might be down to 0.125, which is 1/8 of an inch, to unlimited. So here we would have 0.125 and to unlimited, and then the fillet welds are unlimited in size. The pipe diameter range, 1 inch to unlimited. Again. So you can weld. So this procedure is good for any limit, for any size pipe. So we're giving ranges again. And again, if you want to know the details, go read QW 403, that paragraph. It'll explain everything to you. Then after that, we come down to filler metals. Again, we're going to record the SFA numbers where it says 5.1, 5.1. The AWS number would be our E6010 and E7018. F number, A number, size of filler metals, blah, 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 blah. All that information would be recorded in there. Then, let's see. Now we go to the back side of the paper, and we have position of welding. Well, we qualified it in the vertical up position, so but we know that we've matched the mechanical properties, and so it can be used in any position: flat, horizontal, vertical, overhead, doesn't matter. And incidentally, under ASME, you can actually take plate. You could take some plate and lay it down on a tabletop and just weld it right there, do the necessary mechanical testing to it, and qualify a welding procedure. Some companies like to do that just to get the procedure qualification out of the way. A lot of other companies would do it the way, using the scenario we've been using, so that they can qualify the welder and the procedure at the same time. But under ASME, yeah, you can do a plate qualification using A36, for example, and that would qualify a pipe qualification using SA 106, because the mechanical properties, that they all came out of the same batch of metal at the foundry. They were just poured into different product forms, product shapes. So this proves that the mechanical properties are going to work, so you can do it with plate under ASME. Under D11, if you're going to do a welding procedure, you have to qualify that procedure in every position. If we want to do a plate procedure under AWS, we would have to do a test in the flat position, a test in the vertical position, a test in the horizontal position, and a test in the overhead position. So the code's different. But always make sure that you're working to the code that the work's going to be done under. So, because they all change. It's their little kingdom, and they want to, be God in that kingdom. So you have to follow whatever it says in those codes. So we've got our position. It's good for all positions. Our progression is up, and then positions of fillets would be all. Then we go down to QW 406. So here we have a minimum preheat, and we set that at I think we said 70. So our minimum preheat would be 70 degrees Fahrenheit, and then our inner pass temperature. Well, let's say that for the sake of argument, what we actually recorded was 450 degrees. That's actually a little low. You're not in much trouble, or there's not a whole lot of concern that that's going to make any mechanical changes. So you could easily add another 100 degrees to that, and you could make your maximum inner pass temperature 550 degrees. You're still way down there, but it's far enough below where any mechanical changes would occur that you're not going to get in any trouble. And it would still be low enough that it would avoid undercutting any problems for the welder. So you might just write 550 in there, again, to give them a little bit of a range. And then preheat maintenance, do you want them to keep it from falling, keep that temperature from falling below a certain point? And if so, that has to be recorded where it says preheat maintenance. We're not going to worry about it. However, there is a such thing called interrupted welding. Let's say a guy's out here and he's making a production weld on pipe, the way we've been discussing, and it comes to lunchtime and he breaks down, he goes in, he eats, comes back an hour later, and it's 20 degrees outside. Well, of course, everything's cooled off and gone down. Well, as an inspector, it's kind of tough, but you have to try to do it. Get out there and make sure that he preheats it all back up again to at least that 70 degrees. And that would be called interrupted welding. And sometimes, under some codes, interrupted welding is not allowed. So again, you got to know your codes. Got to know your codes. Post-weld heat treatment, if we have any, what did we do it at? Typically for say you've got something that's 3 inches thick. Okay. You got something that's 3 inches thick. Well, now that's going to require post-weld heat treatment. So the scenario we've been discussing wouldn't apply. But to illustrate what would go in there, you would probably want to preheat post-weld heat treatment that, and that's typically done at about 1150 degrees up to about 1300 degrees, which is just below what's called the lower transformation range. And you're going to take this metal and you're going to heat it up to 1150 degrees over a period of time, over 2 or 3 hours. And then you're going to hold it for 1 hour. Let's see, it's an hour for the first inch, and then it's 15 minutes for each additional hour. So to stress relieve or post-weld heat treat something that's 3 inches thick, we would probably do so for at least an hour and a half at about 1150 degrees. So that's the kind of information that would go in here. And you notice it says temperature range, what are you going to have it at, and time range, how long are you going to do it, how long are you going to soak it. It's called soaking, so how long are you going to soak it. Okay, gases, QW 408. Again, that's not applicable to the procedure we've written, so you can leave that blank or put down not applicable, NA. Usually how it's written, NA, not applicable. Then the electrical characteristics, you're going to fill this information in, and all we're doing now is moving stuff straight over from our PQR to this form. The only difference is now we're going to give them a range. And you notice here it says amps, and it's asking us for a range. Well, a typical range is, if you remember, we did our 60-10, and what we actually recorded was 78 amps. And we did our 7018, and what we actually recorded was 117 amps. It's typical to give them a range of plus or minus 15%. So what's 15% of that? Let's see. 7 be about 12 amps. So our range then would be, say, we would give them a range from like 65 to 90 amps for our 6010. That would be a good range. Again, what we're doing is trying to provide the welder with a little bit of leeway that they'll stay within the procedure, but sometimes they may have a pretty wide gap that's just a little bit wide, and so they have to turn the amperage down in order to make a good sound weld. So you got to give them that leeway to work with. 117, let's see, that'll be about 17 amps. So we'll go down, our range here would be about 100, up to about 135. And that would be a good range for our 1/8 inch 7018. Okay, so there within we would put under amps, we would do our ranges. Voltage, you can record it or not. A lot of times it's not recorded, and if it's not recorded, you could write NR, or you could put variable. And I've seen this a lot on Welding Procedures. Variable in there. Of course, we didn't use tungsten, but if we did, we'd have to record what type was it. Was it pure tungsten? Was it 2% thoriated tungsten? Whatever, that would be going in there. If we use gas metal arc transfer, it's asking, if so, did you use spray arc or short circuiting, whatever. And then the electrode side, electro wire feed speed range, blah, blah, blah. But, of course, all of that information is not applicable to our little scenario. Under technique, well, sometimes a person's going to be wanting to weld in the flat position using this procedure, and if they're welded in the flat position, they're not going to want to use stringer beads. So under technique, we would write string or weave, so that we tell them, okay, they can use either one, doesn't matter. Orifice cup size, that has to do with gas, that's not necessary. Interpass, initial and interpass cleaning, here you would write in the details of what you expect the welder to do. Well, he's going to grind it, grind the mill scale back away, for 1 inch from the joint, blah, blah, blah. He's going to grind and brush as needed each individual pass, blah, blah, blah. All that information would go in there. If they're going to back gouge, then you have to write in here the type of back gouge. Are they going to use an carbon air arc to back gouge, which is typical. Oscillation, again, that's not pertinent to what we're doing here. And then contact to tube work distance, that again would be for gas metal arc, something like that. Multiple or single layers per side, well, they would be multiple or single electrode. We used a single electrode. Travel speed range, again, if you wanted to record that, you could. Peening is where they'll take it's not like hitting something with a chip and hammer, but it's a very aggressive type of peening with a large hammer, and more often than not a mechanical hammer. So some jobs allow peening, some don't. You have to think about the type of steel. If it's a mild steel, peening is not too bad. But if it's a high carbon steel, you may not want to peen, especially if it's just on a root pass, because you could crack out just a root pass with peening. They do peening as a stress relieving process to keep the stresses from building up in the weld. And then any other notes you would write down there. Okay, so that brings us down here to this bottom part where it says weld layer, process, filler metal, current, voltage range, travel speed. So now we're going to put individual stuff in here. Where it says weld layers, you're going to go layer. Okay, layer 1. Process, we used shielded metal arc welding. The class was 6010 because this is the first pass is going to be our root pass. Diameter, we ran it with 1/8 of an inch. Polarity, DCEP, amperage range, what did we say it was? We were going to do 65 to 90. Voltage range, you can leave that blank or put something in there if you want to. 88 to 22, let's say. Travel speed, NR for not recorded. And then any other thing that you might want to mention. Layer 2. SMAW 7018. a lot of times it might be a tight joint, so you might say, well, 332, DCEP. Well, if you use the 332, you can't really run it at 100 to 135, so you'd have to reduce the range accordingly. So you might go 70 to 90 amps on that, blah, 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 blah. 3, go the same thing, 70, 18, and now we're at 1/8 of an inch, DCEP, 100 to 1. All remaining layers similar. Like so. So you can write it out like that. And that would be this information here. And now this is a document that the production people, the people making the weld in the boiler or out on the floor, if they have any questions, they can turn to this, and it's a guide. It's their instructions. And it would be an aid to your foreman, to your lead people, that in guiding their people. Welders are notoriously lazy, and a lot of them they won't read this. So it's an important tool for your supervisory people to be able to know what's expected and make sure that their people, their craftspeople, are following this. You would want to leave these in the area where the work is being done. Make them available to everybody that's involved in the production, in the fabrication of that stuff. And then, of course, if you have to make any changes down the road, then you have to do a revised procedure. And if any of the variables, these are all called essential variables that we've been discussing, if any of them get out of the ranges that we've established, if you move up here and suddenly you decide you're going to weld them at 150 amps instead of staying at 135 or below, now you have to do a new procedure. You have to do it all over again and establish that the mechanical properties are still going to work at that higher amperage. You've gone beyond the essential variables that we've already qualified. So now you got to do it all over again to reflect the new conditions. So that is document number 2. There's one more to go, and we'll be done with this review. So pull out your last document. It is the QW484 suggested format for welder/welding operator performance qualifications, called a WPQ. A WPQ. QW484. That's the document you're looking for. Okay, let's see, we've done that, we've done that, we've done that. Okay, now we're over here now. This is the last one. And I've gone ahead and filled one of these out already. And the very first thing is, again, you're going to put the welder's name up there at the top where it says welder's name, clock number if they have a clock number, stamp number, or ID number. And usually what I'll do is I'll use the last 4 digits of a person's social security number. If I'm doing a test for a person, that's what I'll do. Out on the job, if you're over a bunch of guys, it's very typical to just use a person's initials. Sometimes initials are duplicated, and so you might go AA1 or John Collins 2 or whatever it is, and change it like that. And then you're going to put down here welding process or processes used. Well, we did it with shielded metal arc. How did we do it? We did it manually, or the welder did it manually. And then it says identification of WPS, followed by the welder during the welding of the test coupon. So that takes us back over here to our PQR. Okay? So to qualify the procedure, we would have to write in here, pardon me, the WPS. The guy that did the welding did them both. So here on the WPS, we would have to write in this number, AWC-CS-1. And then the guy that did the test, if you remember back here on the PQR, it was Joe Welder. Joe Welder did the test. So right here we would have to write that information. AWS-CS-1, Joe Welder is the guy that made that test. So there's traceability there. The whole purpose of all of this stuff is, first of all, to make sure that what we say is going to work really will work, and then there's traceability. If for some reason it doesn't really work, they want to be able to blame somebody. So they want to have traceability. So it's all got to have that paper trail. The materials, base metals welded, again we're here at SA 106B, and the thickness was 0.432 because that was the 6-inch Schedule 80. Then we have manual or semi-automatic variables for each process. And here we have the actual values and then the range qualified. Now this form is actually in your textbook. I believe it's on page 5-37. I've given you a blank one in your packet, but they also have this thing in your book, so you can see it there. And so it says backing. Well, we didn't use any backing, so actual values, none. We didn't use backing. But under range qualified, this welder is qualified to use this procedure with or without backing. So that's what's going to go under range qualified. With or without is what we would write in there. And then ASME P number. Well, we did it P1 to P1. But under the ASME code, if a person passes this test, they're qualified to weld on materials that are P1 through P11 plus a couple of others. So here where it says range qualified, you would put P1 through P11, and there's some others in there, and you could go to the code and actually look those up. Here we used pipe, so you would X the pipe, put an X in where it was pipe, and enter the diameter if it was pipe. Well, from our pipe chart that we saw earlier, we know that the diameter is 6.625, or 6 5/8 of an inch. And if you were to look this up in the code book, this would qualify that person to weld diameter pipe as small as 2.875 inches, or just under 3 inches, to unlimited diameter. But there's a lower range that they're qualified for. To get below that range, they have to take a different test. They would have to take a 2-inch test, and then that would qualify them down to 1-inch diameter pipe. Today, there's a new test called the Super Coupon, and that is a 2-inch test. It's a 2-inch double extra heavy, and if you look on that pipe chart, let's see, that pipe chart that I gave you, pipe size and wall thickness, find your 2-inch and go across there and find the double X, and you'll see that double extra heavy is 0.436 wall, 0.436. So that would qualify a person taking that test to weld any pipe down to 1 inch in diameter to unlimited diameter and in any thickness. So a lot of companies are giving that test now. But for the test that we just gave, the person, if they took the test we've been describing, they would be limited to welding stuff that's just slightly over 3 inches, slightly below 3 inches to unlimited. So that's the range qualified. So that has to go in there. Then filler metal specification number 5.1 and 5.1, and then you're going to put the class E6010 and E7018. You're dropping down to the next line. It says F numbers. Well, we used F3 and F4, and now this puts some limits on them. Right here, typically we'll write given filler metal only, because this person didn't qualify on stainless. Well, P8 is a stainless number. Yet the code says that they could weld on P8 material using this process. Well, we want to restrict them, because if you're going to weld on stainless material but you haven't taken a stainless test, then you're asking for trouble. So we will restrict them to the given filler metal only. And if we need them to weld on stainless, that is beyond the range of this qualification then. We limit it so that we won't be having them out there welding stainless when they're not qualified to weld stainless. So we write in that block, given filler metal only. So right here where it says F3 and F4, the next line over, given filler metal only. Then consumable inserts, well, that's not applicable. Weld deposit thicknesses, well, we discussed that earlier, 0.125 and 0.307 for our root pass, and then our filler and our cap. and that qualifies the welder for twice that thickness. So if a welder puts a root pass in with 6010 and that root pass is 1/8 of an inch thick, they're qualified to weld 6010 up to 1/4 of an inch thick. With the 7018, if they weld the remainder of that, they're qualified to weld .307 thickness, or about 3/8 of an inch, with 7018. So now they're qualified to weld twice that thickness. Now a lot of times you don't break it down that much. All you do is go ahead and put the minimum thickness in there, which was typically .067 or 1/16 of an inch, and then twice the thickness of the material that was welded. So that would be, let's see, the thickness was .432, so that would qualify them to weld .864. I know I'm throwing a lot of numbers at you, but I'm trying to show you that there are restrictions within these ranges that the welder's qualified for. And as the inspector, you got to be able to read these papers and make sure that whoever's working on that job that you're responsible for isn't doing anything that is beyond what they're allowed to do. So that's very critical. Welding position, he took the test in the 6G position, so that qualifies him to weld in any position. So you can write any or all over there. Progression, well, we did it uphill. Range qualified, NA, or you could write uphill only, or NA. Backing gas, NA. Gas metal arc transfer, NA. Gas tungsten arc, NA. So NA in all of those. And down here I just put a line through these where it talks about machine, because we didn't use any machine. You can put a line through them or put NA in all of those. A lot of times I'll put NA in the very first one, and then I'll put ditto marks on all the rest of them. And then we come to the guided bend tests. Bend test results is our next thing. And for the performance test, I referred to this a moment ago. You should have this in your packet. It says QW 452 Performance Qualification, Thickness Limits, and Test Specimens. So type of joint, grooves. We've been discussing groove welding on pipe. So the thickness of the test coupon, it's over 3/8 of an inch. So if you come over here, it shows that under the thickness T of deposited weld metal qualified, it says 2T. So they're qualified for twice the thickness. We've already talked about that. And then you come over here and it says, see these notes, and it says face bend 1, root bend 1. So it says type and number of tests required, and they would have to take these. And we'll give them two. We give them 2 bend tests. Okay, these are transverse bend tests. So but you have to look at the notes. And so here it says thickness of coupon, and you read note 1. And I want to say this again. I've said it before. Always remember that the big print giveth and the little print taketh away. So it'll usually set limitations on what can be done. So under thickness of coupons, read note 1. It says, when using 1, 2, or more welders, the thickness T of the deposited weld metal for each welder with each process shall be determined and used individually in the thickness column. So in other words, if we had something that was too thick for one welder to do because he's got limitations, you'd have one welder weld the maximum that he was qualified for, then you have another welder come in and weld whatever maximum they're qualified for, and then the next welder come in, and in that manner, by using multiple welders, you can weld a really thick joint and still not violate the code. So let's move on across here, and it says, see note 8, a side bend test may be substituted for each of the required face and root bend tests. And let's see, under type and number of tests required, it says see notes 3, 4, and 5, so you're going to read those. It says 2 or more pipe test coupons of different thicknesses may be used, blah, 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 blah. It says to qualify, note number 4 says to qualify for positions 5G and 6G as prescribed in QW 302.3, 2 root and 2 face bend specimens or 4 side bend specimens as applicable to the test coupon are required. So even though it says 1 and 1, once you read note 8 over here, once you read note 4, it tells us, well, we really got to take 2. So you're doing 2 face bends and 2 root bends. So always read the notes, because on the face of it, you might think it's telling you one thing, but when you really look at it, kind of like trying to read the IRS code, you know, it'll say, go back to this paragraph, then flip to that table and do this other thing. It can get pretty complicated, so make sure you read your notes. So we would do 2 face and 2 root bins. So you've got that paper in there. And so that information then would be entered here. Face bin, root bin, satisfactory, satisfactory. Visual examination, acceptable. Radiographic test results. Well, ASME allows a welder to do a production weld. You can actually put a person out there and he's not tested. But you've got to x-ray the first production weld that he does. And if that passes, then they're acceptable they're qualified by x-ray, because x-ray is considered to be a soundness test, the same as bin testing stuff, because it's looking for any discontinuities or defects within the weldment. So you could do that, and if you want more information on that, look at QW 304 and QW 305. Those are the paragraphs, again, in Section 9. And a lot of companies will do both. They'll have you do a test coupon, and they'll x-ray it, especially on that 2-inch. They'll x-ray it, and then they'll go ahead and bend it. Most welders nowadays are qualified just on that 2-inch super coupon by x-ray, and they'll forego the mechanical testing. But a lot of them will still require it. Fillet weld, fracture test, not applicable. Macro etch test, not applicable. Welding test conducted by, in this case we would say Western Wyoming Community College. Mechanical test conducted by Western Wyoming Community College. And then again, you're going to put your laboratory test number. Now this has to be a little bit different from the test number that we used previously. And again, the way I would write something like that, I would probably write something like, let's see, lab test number, whatever company it is I was testing for. Let's say Acme Welding. Okay, Acme Welding dash. He's the 4th guy I've tested. 04-06. So it's still similar, but it's got to be unique. And I record all of these things in a separate logbook. I have a logbook in my office where anytime I've done a test, a certification test for anybody, not only do I keep a copy of the papers for 5 years, but that test and all this information is recorded in my journal, in my logbook. Then finally, I like to add a line over here where it says certified by or qualified by, and that's where I'll sign, and then the date, and then where it says organization, that's the company that the testing was done for, and then the responsible party within the company that is accepting that test. Sometimes the person doing the test will be the same company representative. Sometimes it will be a designated person. Say somebody that's really experienced with welding would do the test, administer the test, and then the welding engineer or plant engineer or project engineer would sign off as accepting responsibility. Because it's not really necessary under the code to be a certified welding inspector to conduct welding tests. Most companies want you to be. But under the code, you could be a person designated by the company to fulfill that responsibility. But then the company is accepting your judgment. And that's why most companies want to protect their butts, and so they're going to have you know what you're doing and go through a course similar to this one to be a CWI before they're going to foster that responsibility on your shoulders. So that's the last document, and I hope that explains a little bit in terms of understanding how these things work. Let me go over a couple of other documents that were in your student packet. Here we have welding data. It says QW 461.9, performance qualification, position and diameter limitations. Under our example, we were doing pipe groove welding, and we did it in the 6G position. So you'll come down here where it says position, come down, it says 6G, and you come across here, and that qualifies a person to weld in all positions. And you just go right on across there and you see it's all, and all. So I put that in there for your personal use. And then the final document, actually there's 2 more. I gave you this. It says basics for welding before you strike an arc. So read over that, and it talks about, well, step 1, step 2, step 3, step 4. These are the things that you've got to do to get from concept to fabrication and to do it within the code. And then finally, I sent you a more detailed one It's written out a little bit more. It says procedure qualification record. Remember, this is where it all starts. This records the actual values, what's in it, contents of the PQR. And then I've got mine kind of doctored up here. I've got a lot of stuff highlighted. Read over that. It talks about what is an essential variable, what's a non-essential variable, what's a supplemental essential variable, what are the acceptable or qualified ranges, and so forth and so on. So all that information should help you to understand how this paperwork works a little bit better now. And this is going to be important to you, especially when we get into some of the other stuff, when we go over the API 1104 code, when we go over the Part B of the CWI exam. And also I'm sending home a 50-question test, which is extra credit. You may have already done this, but if not, there'll be one in this packet. And there'll be some questions in there about what we've just discussed. So if you have any questions, feel free to contact me, but I hope I haven't confused you too much with all this documentation. Thank you very much.